With the successful splashdown of Artemis II, we have seen that humanity has gone and achieved a milestone for deep space exploration. But when we are talking about the splashdown, we have to place a special emphasis on re-entry, which is one of the most critical and also vulnerable phases when we are talking about the return of the space flight. So Artemis II needs to be celebrated, but at the same time it serves as a very important case study that how it sets the path for upcoming crewed mission across the globe. Hello everyone, welcome to Vajiram and Ravi's Flash News. My name is Shubhangi Singh and today we are going to talk about Artemis II. When we are talking about this particular space flight, this has been hailed as one of the most important contribution in recent times, not just because of the distance it covered, but also the fact that how it was a complete mission and rather a perfect mission. So when we are talking about this specific mission, it has also broken a record where this has been the longest or the furthest away from Earth that the astronauts, that means humans, have travelled to, almost 4,06,000 kilometers away from Earth. Now when we are talking about Artemis II, this particular mission, this has successfully returned as of now, and if we look at it, we clearly get to see that this was a lunar flyby mission. Why we are seeing flyby? Because it did not land on moon, it went around. So let us see how it has gone to the moon and come back. So April 1st we saw the launch and then it took a Earth orbit, that means it went around Earth. 24-hour orbit was done to ensure that all systems are in place even after launch and everything's fine. After that began the journey to the moon. Now after the orbit, there was a translunar injection burn which sent this Orion spacecraft towards moon, and around 3-4 days went in the transit to reach the moon. Now next 2 days were for the flyby, the lunar flyby that we are talking about, the moon flyby. So during this time, around 40 minutes flyby happened where the crew took detailed photos and videos of the moon surface, and then began the return journey. Now because of the moon's gravity, there was an automatic throw towards the sun which Orion spacecraft had the help of, and then on April 11, that is today, we saw the splashdown. That means the crew module returned safely after full 10 days of mission in the Pacific Ocean, and this splashdown happened near San Diego. Now when we are talking about this travel, which is more than of 4 lakh kilometers, it is a record in itself. But another critical important part is the return, ensuring that this mission was complete, because when we are talking about the re-entry into the Earth's atmosphere, the speed is as high as 11 to 12 kilometers per second. That means you are looking at 40,000 kilometers per hour. And this is where the multi-stage parachute system helped for a safe splashdown. So we will be breaking this down and understanding it better. In yesterday's session, I have already covered in detail that how India's Gaganyaan mission is already preparing for the re-entry. So we discussed about the integrated airdrop test. Now this is the executed form of the whole airdrop test and also the successful landing of crew that has been seen from NASA's end. Now moving ahead and understanding from scratch that what exactly is re-entry. Re-entry basically means, as the word goes by, that the crew module is going to, the whole thing is going to enter the Earth's atmosphere and gradually move towards Earth's surface. So if you see in this particular diagram itself, you can clearly see that it is in Earth return orbit, then entry maneuvering is done, and gradually once it enters the Earth's atmosphere, parachutes are deployed when the altitude is somewhere around 5 kilometers. So these are present stages where the atmospheric interface happens at the altitude of 120 kilometers. Now after the entry, because of the velocity, there is peak heating which also leads to plasma formation. And because of the speed at which it is coming, and there is slowing down, there is rapid deceleration as well. That means high gravitational forces are working in the opposite direction. And then we get to see that the deployment of parachute takes place. First, drogue parachutes are pulled out, and then main parachutes are deployed, and finally the landing takes place in comparatively calmer waters. Now, two important things that here we have to understand, that there is a huge role of kinetic energy that we understand and calculate through half mv square, if you remember from your science classes. This is where kinetic energy gets converted into heat and drag, which can lead to the destruction or any problem in the whole crew module. And also the re-entry has to be done at a proper angle, which is the flight path angle. If the entry is at steep angle, then the burn up will be very high, and if it is at too shallow of an angle, then it might skip off the entry into the atmosphere altogether. And this is where we get to see multiple critical situations and things that can go wrong, making the re-entry phase very difficult. And in this scenario, that is why this particular mission is also being celebrated, because this has been executed in total perfection. The completion of mission marks that the re-entry has been done in the best possible way here. So when we are talking about re-entry, we also need to understand why it is so challenging. First thing I have already mentioned, I have talked about angles. Second, we have also briefly discussed is about the heat. The heat that is generated is so extreme, it is almost 1500 3000 degrees Celsius. The speed is hypersonic. If at all there is angle error that we are talking about, it can lead to a disaster. Other than that, because of the speed and heat and also the pressure which is present, the structural stress on the module is very high. Apart from that, this is the place where this communication blackout, because of plasma sheath which is present, plasma formation which takes place, high gravitational forces, and precision landing is very much required, otherwise it might be causing an accident furthermore. So in this situation, re-entry becomes the most critical phase of mission's life cycle. The completion of mission depends on this phase, and that is why it needs to be executed despite the huge challenges that we are talking about. And because it is so challenging, in past we have seen multiple accidents which have caused, especially when we are talking about lunar missions. For example, STS-107, yes, the very same one from which Kalpana Chawla was coming back. There was a heat shield damage while the launch, which led to a disintegration of the crew module during the re-entry, and all the crew members died. This happened back in 2004. We have also seen other missions such as Apollo 1, Suez 11, where the fatality and accident has been caused in the re-entry part itself. And this is majorly concentrated especially in lunar missions, and this comparison will give you a very clear idea. So if a mission is towards International Space Station, the distance is 400 km. The maximum speed that we are looking at is 28,000. The heat is moderate and the risk is high, yes, definitely. But when you look at the numbers for lunar missions, the numbers here double up. The distance here is more than 3,84,000 kilometers. We are talking about speeds above 40,000 km per hour, and heat is not moderate, it is extreme. And that is why, because this is more challenging, we have seen multiple accidents in lunar missions, especially as compared to International Space Station missions or lower Earth orbit missions. Now, as much as the accidents have been unfortunate, these failures have led to redundancy systems, better materials being used, and stricter safety protocols, and as a result we see Artemis II, a feat for humankind to look forward to deep space exploration and more. And it becomes very important that in coming times we do take this learning as well as the achievement in direction where it can facilitate better explorations, but at the same time reduce the incidents and accidents that have been caused. Now on this note, I will be leaving you here with the prelims practice question. Let me know your thoughts on this particular topic and also answer this question in the comment section. That was all from my side. Thank you so much.